Taylor series matrix we have already finished. Indeterminate forms. Okay, so unit 2 indeterminate forms is limit when you are finding it here and you got the values of 0 by 0 or infinity by infinity, 0 into infinity, infinity minus infinity, infinity to the power of 0, 0 to the power of 0, and 1 to the power of infinity. These are the 3, 3, 6 and 7 indeterminate form is there. Okay, these are 7 indeterminate form called as. When the value has come 0 by 0, infinity by infinity, or 0 into infinity, and so on, so we cannot find the values in these situations which do not represent any values. So such expressions is called as indeterminate forms. So the French scientist was in 1961, 1661 and 1704. Okay, during this one here, that French Air Hospital is given the rule to find when the limit comes from the indeterminate forms. Okay, so Air Hospital rule is there to find it the limit. Air Hospital rule. So Air Hospital rule only applicable for 0 by 0 and infinity by infinity, not for other. Okay, when the indeterminate forms is 0 by 0 or infinity by infinity, then only we can apply the Air Hospital rule. Okay, so what will be the limit of, consider if any function given here a, f of x by g of x. So you substitute the values whatever the given here, x tends to a. In the place of x you put it a here. If you got it 0 by 0 or infinity by infinity, then you can apply the Air Hospital rules. And Air Hospital rule is what here? It just differentiate numerator and denominator separate, not u by v. Separate, differentiate numerator and denominator, and then substitute the values here. Again, if you are getting 0 by 0, then again you differentiate and substitute the value of x tends to a. You keep doing here till you get the constant values. Getting here? So this is the Air Hospital rule here. Now another forms if you given here, like 0 into infinity or infinity minus infinity. This is only when the form of 0 by 0 or infinity by infinity. Okay, so note I will write it here. First note here, Air Hospital rule only applicable for the indeterminate forms 0 by 0 and infinity by infinity indeterminate forms. Indeterminate forms. Okay, if the limit is what in the another forms like 0 into infinity or infinity into 0, that time you take the LCM. Okay, yeah, you can write here 0 into infinity and infinity into 0, yeah, infinity minus infinity, something is given like this here. So that time rewrite the functions. Involved, or take the LCMs and simplify. Take the LCM and simplify and arrange LCM to arrange in form of either 0 by 0 or infinity by infinity. Okay, so what you have to do, just you have to take the LCM and you have to convert it in the form of by normal algebraic simplifications. Okay, and last one is what, third one, if you the indeterminate form in the form of that infinity to the power 0 or 0 to the power 0 or 1 to the power infinity to given here, these functions. Okay, that time we have to take as a logarithmic functions. Okay, then take the log both side. I'll take the example here. Okay, take log both side and simplify and express in form of express functions in form of 0 by 0 or infinity by infinity. Getting it? We'll do one by one first. Okay, so they will not mention here in the examinations which form is given. You have to substitute the values and check out. Okay, so if you substitute the value x tends to 0 is given, put the value of x. So 0 into anything is 0 here, minus this is log 1 plus 0, log 1 is also 0 divided by 0, which means here 0 by 0 form is given. So 0 by 0 form is given, so directly we can apply the L'Hospital rules. So what is the L'Hospital rule? Numerator differentiate and denominator differentiate separate. So when you are differentiating this one here, so we have to apply u into v formula because two function is given, right? So x into e power x differentiation is e power x plus e power x as it is only, and x differentiation is 1, minus log differentiation is 1 upon 1 plus x divided by this x square differentiation is 2x. Now you put the x tends to 0 here. So x tends to 0, so this part will be 0. Alright, with a different color. This part is what? 0 here, because 0 into anything is 0. This one e power 0 is 1. This is 1. Minus this one, correct? You can substitute it here and better you can show that in the examination also. This is what? 0 plus e power 0 is 1, minus 1 by 1 plus 0 is 1 here, divided by 2 into 0. So you can write again 0 by 0 form. So again you differentiate. So again means this is u into v, x into e to the power of x plus e to the power of x, and e power x differentiation is e power of x, minus 1 by x differentiation is plus of 1 by 1 plus x square. Okay, differentiation of 1 by x differentiation is minus 1 by x square. Okay, divided by the denominator is what? 2 here. So now you substitute the x tends to 0. So this will be 0 plus e power 0 is 1 plus e power 0 is 1, and this is what? 0 plus 1 is 1. So 1 by 1 is 1 only, divided by 2. So you got it 3 by 2. 3 by 2 is a constant here. So this is our answer. Getting here?
Yes, sir.
So now we proceed.
The answer we should direct differentiating it.
Yeah. So now we can see here. Next questions. Given our limit of x tends to pi by 4, and is given secant square of x minus 2 tan of x divided by 1 plus cos of 4x. Okay. So now we first put it this x tends to pi by 4, which is given. Sec pi by means sec is reverse of cos. Cos pi by 4 is 1 by root 2. Okay, 45 means this pi by 4 is 45, right?
Yes, sir.
The cos 45 is 1 by root 2. So root 2 square becomes 2 only. This becomes 2 here. Minus tan pi by 4 is what? 1. 2. Plus 1 plus cos of 4 into pi by 4. Cos pi. Cos pi is minus 1. So minus 1 becomes 0 here. So 0 by 0 form is there. So limit of x tends to pi by 4. And now you can differentiate, because this is 0 by 0 form, means we can apply L'Hospital. Apply L'Hospital rule. So L'Hospital rule means numerator differentiate. Secant square differentiation is 2 secant of x into tan of x. Okay, this one secant square differentiation is 2 secant of x into tan of x into 2 secant square differentiation is 2 secant of x, and again sex differentiation is secant x into tan x. Minus into 2 as it is only. Tan differentiation is secant square of x divided by 1 is 0 here, and cos differentiation becomes minus of sine of 4x into 4, right? This one 4 minus here. Now you put pi by 4. Tan pi by 4 is 1. This is 2. This is 2. Right? So how much this one becomes here? 1 minute. I will write this one, I will rearrange. This one you can write 2 secant square x into tan of x, right? Minus 2 secant square of x divided by minus 4 sine of 4x. This one you can write it here. Put it here, this one. Check pi by 4 is 2. 2 to the 4. Okay, 4 to the 8. This is also 8. So 8 minus 8 becomes 0 here. And this is sine 0 also 0. So this is again 0 by 0. So you have to again differentiate. Okay.
Okay.
So limit of x tends to pi by 4 here. U into v have to apply here. Okay, yeah, better you take the common and then you 2 secant square of x, you take the common here. Into tan of x minus 1 divided by minus 4 sine of 4x. So limit of x tends to pi by 4. This one you differentiate, u into v. This you can cancel it if you want. So minus 1 by 2 is there. Here u into v. So this is u, this is v. Secant square as it is only. Tan differentiation is secant square of x. And 1 differentiation is 0. Minus 1 plus here. Tan of x minus 1 as it is only. And secant square differentiation is 2 secant of x into secant of x into tan of x. So becomes secant square of x into tan of x divided by 4 sine. This become 4 sine again sine 4 cos of 4x. Getting?
Sir, actually you have cancelled that, right?
Yes, this 2 I have taken already outside. Don't mix up, otherwise with plus or minus will confuse and chances will get wrong. Okay, so better you take outside. So now you substitute the values pi by 4. So pi by 4 if you put there, this is 2. This is 2. So 2 becomes here that 4, right?
4.
This is 4. This one plus. This is 1 minus 1 is what? 0 here.
0.
Okay, tan 45 is what? 0 here. So this whole term is what? 0 here. Because multiplication is there, no? Everything is 0. Divided by that 4 and cos 0 is what? How much? 0 only.
0.
Okay? 0 only. Cos 0 is what? 1.
1.
So you'll get it here how much? That becomes minus of 1 by 2. Next question, one more you see here. Question is given limit of x tends to 0. Log of 1 minus x square divided by log of cos of x. Okay, you substitute 0 here. So log 1 is what? 0. And this one is what? Cos 0 is 1. So log 1 is also 0. Limit of x tends to 0, differentiate here. So this one differentiation is 1 upon 1 minus x square into 1 is 0 minus 2x. Right? And this one differentiation is 1 by cos of x. And cos of differentiation is minus 7. Very good. So this one minus minus cancel here. So I will take as a limit of x tends to 0. This one go up. So it will go cos of x and 2 of x, right? In the numerator. In the denominator will be sine of x into 1 minus x square. Ended up till here. So you keep in mind here this one limit of x tends to 0 if given sine of x by x, or limit of x tends to 0 x by sine of x. In case of tan also, tan of x by x or limit of x tends to 0 x by tan of x. If you given here all value is what? 1 only. All value is 1 only. So here I can write x and sine of x. Okay. And since x tends to 0 is given, so I can write this one as a 1. Getting here?
Yes, sir.
So what will be left here? Will be left here 2 cos of x
2 cos of x
into 1 minus x square.
of x.
Now you put it 0 here.
0.
Cos 0 is what? 1.
1.
So it will become 2, and this is what if you put 0 here, so 1 minus 0 square is 1 only. So it will be 2 by 1 is what? 2 is the answer. Any doubt in this? Okay, so this property if you use becomes a very like a easy only, because otherwise again you have to do u into v will become complicated. Okay, so this property, this is a property you can keep it down. So all question you can try like this only. Okay, now we'll do type 2 where the indeterminate form is 0 into infinity, yeah, infinity minus infinity. Getting? So consider question is given here. Limit of x tends to 0. Tan of x minus x. Okay. By x square tan of x. So put it 0 here. Tan 0 is what? 0. And this is also 0. This is still 0 by 0 form only. You can do it like the same only. Okay. So see here, this type, whenever the trigonometric question comes here, if you do by multiplication, it will become complicated here. Getting here? If you is trying to do here a differentiate numerator and denominator, will come complicated. So better what you do, which one property I said, that one you can try it here. Okay, x square is there, and this is tan of x. So I can divide with x and multiply with x. Value will not change. So this one I can make it 1 only, right? So limit of x tends to 0, tan of x minus x divided by x power of 3. This one will be easy to find it. Compared to this one, to multiplication is what u into v will come complicated, right? So now, but keep in mind here, this x should be tends to 0 only. If pi by 2 or something else given, so you cannot write here 1. So now you can do it, limit of x tends to 0. Still this is 0 by 0 form only. So differentiate here. Tan differentiation is what? Tan differentiation? Second square of x minus 1 divided by 3x square. Right? 3x square. And limit of x tends to 0. Second square, you know that second square theta minus tan square theta is equal to what? 1 only. So second square minus 1, I can write tan square of x divided by 3x square, right? So limit of x tends to 0. If 1 by 3 to take outside, this one I can write it here, tan of x by x whole square, right? And this value is what? How much? 1 only.
1.
So 1 by 3 into 1 square is what? 1 by 3 only.
1 by 3.
So this is the answer you can write it.
Okay.
Getting?
Yes, sir.
So if infinity by infinity is given, same only you have to do it. Okay, one more question, so I will do it for the infinity by infinity. Limit of x tends to 0, consider it to given here. Log of tan of 3x and base is given here, tan of 2x. Okay, 2x. So keep in mind this property here. First, log of if you given a and b. So you can write in the any base here, log of a in base of e, because this is calculus here, so always you write in the base of e, divided by log of b in base of e. I can write it. I can write separate. Getting?
Yes, sir.
So I can write it here. Limit of x tends to 0. Log of tan of 3x. And you always will be base of e, so no need to write here, because in calculus always base is what? E only. And log of tan of 2x. Getting here? Now you put it 0 here. Tan 0 is what? 0. So log 0 is what? Infinity. This is also infinity. Infinity by infinity forms.
Okay.
So infinity by infinity form is given, so we have to, you can apply the L'Hospital rule, right? So 1 by tan of 3x into tan differentiation is second square of 3x into 3, right? This is 1 upon tan 2x into second square of 2x into 2. Any doubt in this?
No, sir.
So if you simplify here, limit of x tends to 0. Tan I can write cos by 3. This one. Sin by cos, right? Sin by cos, so cos will go up, cos 3x by sin 3x. And this one I can write 1 by sin square of 3x. Cos square of 3x, sorry. Sec is there, no? Cos square of 3x into 3 as it is only, right? Similarly, tan I can write here cos of 2x by sin of 2x, and second square I can write 1 upon cos square of 2x into 2. Any doubt till here? So now here we can cancel anything. This one is cancelled here. This one is one part is cancelled here. So limit of x tends to 0. I can write this one up. So what will go up here? Sin 2x into cos 2x, and 3 will be as it is only, and this will comes here. Okay, just a minute. 2 sin of 3x into cos of 3x, right? Cos 3x. So if you want, you can write limit of x tends to 0. This one if you multiply 2.
Actually, down is 2 different.
Sorry? This one you can write here. See here, this one I can write if 2 multiply here. I can write it here. This is 2 if you multiply becomes here 3 as it is only. 2 sin of 2x into cos of 2x. So I multiply 2 here, so I have to divide it also 2. Okay? So this becomes 2 into sin of 3x into cos of 3x, right? Just I multiply and divide x with 2. Why I did? Because I can write 2 sin x into cos x. I can write it here. This one is sin 2x becomes 4x, and this one becomes 2 as it is only. This one is sin of 6x. Okay, because 2 sin x, 2 sin into cos b is what? Sin 2x. So now limit of x, now you put it x tends to 0. So if you again will put it here, you will get 0 by 0 only. So again differentiate. Limit of x tends to 0. If you differentiate this one, will comes here 12 cos of 4x, and this one becomes 12 cos of 6x. Any doubt in this? So now if you put it 0 here, so cos 0 is 1. This is also 1. 12 by 12, which is 1. So this is the answer. So now we'll do it in another indeterminate forms, which is 0 into infinity and infinity into 0, yeah, infinity minus infinity. This one meaning is both are same only. So consider if you given here limit of x tends to 0, x into log of tan of x. So put here 0 is what? This will get 0 into tan 0 is what? 0, log 0 is infinity. 0 into infinity. So something you have to do and have to convert in the form of 0 by 0, infinity by infinity. So this log tan x you cannot do anything, but this x you can bring it down, because I want something to be bring in the numerator and denominator, right? So if you write it here, this log of tan of x you write as it is only. This x I can bring it down, I can write 1 by x.
1 by x.
Getting here?
Yes, sir.
So 1 by x, if you, now if you substitute here, now you substitute the values, you'll get it. This is infinity already, 1 by 0 is also infinity. So now I can apply the hospital rule. So 1 by tan of x, and tan differentiation is secant square of x. And this one becomes 1 by x is minus 1 by x square. Any doubt in this? So limit of x tends to 0, if you simplify, this x square will go with the secant square. So secant square, x square, secant square of x divided by tan of x. So this one 1x you can take here and we'll make it 0. Will make becomes 1 here. X by tan of x. So only will be x into secant square of x. Any doubt in this?
No.
Because this 1x, if you take it here, I will write tan x becomes 1. And minus will be as it is. Now you put it 0. 0 into this 0 into secant square 0 is what? 1. 0 into 1 is what? 0 only. This is the real number. So this is the answer only.
Okay.
Getting here 0 by 0 into 1 you are getting here. 0 into 1 is a real number. 0 into 1 is something is 0. Getting here?
Yes, sir.
So like that only you have to convert it in the form of another form. So like limit of x tends to 0 given here and given secant of x minus tan of x. So sec 0 is what? Sec 0 is cos 0. Cos 0 is 1. So, sorry?
X0 is 0, sir.
Cos 0 is no. Cos 0 is 1, no.
Yes, sir.
Sec 0 is what something? Sec theta is equal to 1 by cos theta. Cos 0 is what? 1 here. So sec 0 is what? 1, not this one. 1 minus tan 0 is what? 0.
Tan 0 is 0.
Okay, 1 so why is given there? Sorry. This x is 0 is not given, pi by 2 given. If 0 is given, then you are getting the real number. Okay, 1 minus 0. Okay, pi by 2 given. Sec pi by 2 means cos 90. Cos 90 is 0, 1 by 0 is infinity, and tan 90 also infinity.
Okay.
So we cannot do apply here hospital. First we have to convert it in the form of 0 by 0 and infinity by infinity, right? So secant of x I can write 1 upon cos of x.
1 by cos theta.
And the sin y cos I can write for the tan. So limit of x tends to pi by 2. I can write it the numerator is this denominator cos of x LCM into 1 minus sin of x.
1 minus sin.
Now you substitute the values here pi by 2. Let's check here. Sin 90 is 1.
1.
Sin 90 is 1, so 1 minus 1 over is 0 and cos 90 is 0.
0.
So limit of x tends to pi by 2. I can write here. This one differentiation is 0 and this becomes here minus cos of x and cos x becomes here minus sin of x. So this one cancel here. Pi by 2 if you put here cos 90 is 0, sin 90 is what 1. 0 by 1 is what? Real number only, that will get 0. Any doubt here?
Okay.
So this is how limit in form of zero to the power 0, infinity to the power 0 and 1 to the power of infinity. Getting?
Yes, sir.
So let's consider question given here, limit of x tends to 0. Tan of x to the power of cos of x. Okay. So what I said, this question if given, then left hand side you assume as a k. And whenever you put the values, tan 0 is what? Tan 0 is 0 only. 0 to the power. Cos 0 is what?
1.
Cos 0 is 1 only. Okay. 1. This is pi by 2 given. Okay. This one limit of x tends to pi by 2. Okay. This is tan of x and cos of x. This is the question. Put it. Tan 90 is infinity and cos 90 is 0. Infinity to the power of 0 form is given. So whenever the something power portion comes in the limit, take the log both sides.
Take log of that.
So what you will get here, log of k is equal to, this will comes down.
Log cos.
Limit of x tends to pi by 2. This becomes cos of x into log of tan of x. Getting here? Because log of a to the power m is what? M into log a, right? Now here log of k is equal to, you can write it here. This one, limit of x tends to pi by 2, if you put it here. Cos 90 is 0. Okay? And this one 0 into infinity form is getting here. So you cannot do it here. Still this is not come here in the form of 0 by 0 or infinity by infinity. So what I will do it, log of tan x we cannot do anything here, so just like as it is only. And this one I can write it down. Okay, this one 1 by cos I can write sec.
By cos. Secant.
Second I can write it secant theta. So I can write it here, this one is what in down here, that is 1 by cos which is secant of x. Now you put it here, this is infinity and sec 0 is also infinity, right? So now you can apply the hospital. log differentiation, log of tan differentiation is 1 by tan
1
of
by 1
x.
plus.
Tan of x differentiation is secant square of x. Divided by sec differentiation is secant of x into tan of x.
Okay.
Getting?
Yes.
So now we have to simplify. Limit of x tends to pi by 2. What to write here? This will go up. This will write sine by cos. And one cos will be cancelled here.
Yes.
So I can write here this one is what numerator cos of x divided by this one secant of x is what sine by cos, and this is cos. Will come cancel here and get it sine square of x. Directly I have done.
Yes.
If you simplify, you can separate, you can do it and you can try it.
Okay.
Okay, yeah, you can directly have tan cancel here, and this one is what tan won't cancel. Sec will cancel here. Okay,
Yes.
and you can do it. So now pi by 2 you put it. Cos 90 is
Cos 90 is
0 and sin 90 is 1. So 0 by 1 is what? 0 only. That is a real number. So we got it log of k is equal to 0. So k is equal to what? E to the power of 0, which is 1. So limit value what actually is 1 only. Getting?
Yes.
Which is very important question. This one asked so many times. Limit of x tends to 0. A power of x plus b to the power of x plus c to the power of x by 3 to the power of 1 by x. Okay, this is the popular and important questions. So here also we have to put the 0 here. So 0 you put here. A power 0 is 1, 1 and 1. 3 by 3 becomes 1. And 1 by 0 becomes infinity. Is 1 by infinity forms.
1 by.
So take the log both side. This becomes log of k is equal to this limit of x tends to 0. This 1 by x will come down here. Okay.
1 by.
And log of this one here. Log of just like this ax, bx and cx divided by 3, right? So log of m by n I can write log of m by n I can write it here. Log of m minus log of n. So I can write here log of ax plus bx plus cx, that is m only, minus log of 3. Any doubt in this?
No.
So I can write limit of x tends to 0 here, that is x. Okay, x is there for the overall, not only for the x. Okay, this is overall. So log of ax plus bx plus cx minus log of 3. Just I rewrite. 0 you put here. 1, 1, 1. Log 3 minus log 3 is 0 and 0. 0 by 0 form is given. So we can differentiate, apply the L'Hopital rule. Log differentiation is 1 by everything. A power x plus b power x plus c power of x. And a power x differentiation, a power x into log of a. Plus inside you have to do it. B power x is b power x into log of b. Plus c power x into log of c. Okay. Minus log 3 differentiation is 0 only. This is a constant here, 0. Divided by x differentiation is 1. Okay. So now you put 0 here. So this is 1, 1, 1. So becomes 1 by 3.
1 by 3.
And this one becomes a power 0 is 1, but log of a will be there. Log of a, log of b, log of c. So I can write here 1 by 3 log of m plus n plus q is given to log, you can write a, b, c. This is log of k left hand side. So log of k left hand side, and this one I can write log of a, b, c to the power of 1 by 3. So log you can eliminate here. Don't write cancel here, eliminate is called as, okay. Log eliminate. So k is equal to, will get it here, a, b, c to the power of 1 by 3. This one. This is the important asked so many times.